Assalamualaikum and hi, I am Muhammad Khairul Ikhwanuddin Abdul Aziz. So today I will present regarding the infrastructure part in our project. So without ado, I will explain or introducing to you all about this company. So our company is a well-known company that capable to build big areas of site where we can handle around more than 15 acres land across Malaysia, and we targeting to make it full in quality, safe in environment, and safe in health. So next, we move in the what do we call the project background. So in the project background, so project name is Cadangan Membina Perumahan, and the site area is around the Keluang, Jalan Keluang and Mersing, where the project will start on March 2020 and end by April 2022. So here, the developer is Green Berhad, and the architecture is UTHM, and the planning is to build 60 unit of double story houses where the houses lot is around 24 feet to 70 feet for each of the house, and area for this project is 10.56 acres where the budget is there. And so our vision for our company is to become the best and competitive company across Malaysia. And the mission is to provide the best quality using the technology in our construction and so on.
Okay, now I will talk about the infrastructure activities that involved in our project. Okay, first of all, for the earthwork, for the proposed level, okay, enough temporary drainage should be supplied during the building of earthworks. The earthworks contractor should examine the drainage solutions that are necessary and utilize their expertise and experience to guarantee that the temporary drainage provided is adequate. Okay, the proposed level that has been chosen for this project is 56.12 meter. This is because, according to the earthwork arrangement, the projected level closest to the sedimentation pond is 56.10 meter. As a result, by maximizing the appropriateness of excavated material and minimizing the possibility for material corrosion or work instability, this also ensures the success of the earthworks. Okay, this is the temporary earth drain layout. Okay, the red line is the existing drain, and the blue line is the proposed perimeter drain uh, in our project. Okay, next, sedimentation pond. For proposed sedimentation pond location, okay, the use of temporary ponds for sediment management is commonplace on many building sites. After the construction phase, these ponds are occasionally rebuilt and utilized as permanent stormwater control ponds. Additional depth is necessary for sediment storage in between cleanup process. As a result, the proposed sedimentation pond's closest platform level is 56.12 meter, and the proposed sedimentation pond's depth is 2 meter. So the sedimentation pond's level has risen to 54.12 meter above sea level. The proposed sedimentation pond level. The nearest platform level to the proposed sedimentation pond is 56.12 meter. The depth of proposed sedimentation pond is 2 meter, and sedimentation pond inward level 56.12 meter minus 2 meter, and the value is 54.10 meter. So the level base of sedimentation pond is 54.12 meter from the sea level. Okay, wash through. To remove silt from the tires of automobiles leaving the site, a wash through should be built at the property's entrance. The silt trap should be connected to the wash through so that the tires may be cleaned before they are used on the road outside the building site. As a result, the wash through that has been determined is carried out at the building site's entrance. The purpose of creating a wash through is to contain and treat wastewater for drainage to a sewer. Okay, grid method. Okay, the grid method involves drawing a uniform grid onto a plan of the earthworks project and taking off the existing and proposed ground levels at each grid node. With these values, the average depth of cut or fill required on each cell of the grid is calculated, and the volume for each cell is obtained by multiplying the depth by the cell area. Adding the volumes for each cell together, the total cut and fill volumes for the project can be estimated. The average cut or fill depth determined for each cell in the grid. From this depth, the volumes of each grid cell can be calculated, and by adding the cell volumes together, the total cut and fill volumes are obtained. Okay, next, we go to summary of earthwork. According to the calculation shown, summary of earthwork quantity can be made as follows. Cut volume is 40,011.35 meter cube. Fill volume is 3,730.25 meter cube. And for the percentage of difference between cut and volume is 7%. Since the percentage difference between cut and fill volume is below 10%, there is no imported soil is required.
Right, so I'm gonna continue with the water reticulation. So what is water reticulation? Water reticulation is a system of distribution networks of the water, and usually it controlled by the local government entities, and water flow controlled by using gravity, as we can reduce the cost in construction of the water reticulation itself. So in this project, we are designing for 60 double stories houses, and we are planning to cut all of the costs and become environmental safe. Right. Next, we continue with the proposed value of sluice valve. The sluice valve proposed quantity is 3, and the diameter of it is 150 to 375 millimeters, and the skull valve is we propose of one the quantity of 1 and diameter of 150 and 200 millimeters, and installation around 100 millimeters, 100 meters. So for the fire hydrant, proposed quantity is around 5. Next, this is the water reticulation diagram. So next slide. Water demand for this site is around 105,890 liters. So the new proposed level for our site is 62.63 meters, and the existing is also 62.63 meters. So we can see here that distance of tapping point to bulk meter is around 5 meters, and distance from bulk meter to suction tank is around 7 meters. And then having a calculation of the tapping point to bulk meter, residual head pressure at bulk meter is around 27.596 meters, and the bulk meter to suction tanks, the residual head pressure at bulk meter is around 27.592. So this is value is acceptable for our water reticulation proposed system. So that's all from me. We continue with the next slide.
Okay, next, I will explain about sewage. The proposed sewerage design detail. The sewerage line will be installed along with manhole. The sewerage is installed at high place, and the end is at STP, where STP is the lowest place. It is required a 1.2 meter depth of soil cover over the sewer shaft. Normally, 150 millimeter is the minimum size of sewer shaft for residential. Uh, a 450 millimeter size of sewer shaft will be used for sewerage. Okay, this is the proposed sewerage layout plan in our project. Okay, next, this is the example calculation for MS1. Platform level is 64.8 meter, while manhole depth is 1.5 meter. So to get the invert level, platform level minus depth. So 64.8 minus 1.5, and the value of the invert level is 63.3 meter. Okay, next, the example calculation from MS1 to MS2. Okay, the value of x is 25 divided by 200 is equals to 0.125 meter. So the depth of MS2 is equals to depth of MS1 plus x. So 1.5 plus 0.125, and the value is 1.625 meter. Okay, next, for the invert level for MS2 is equals to PL2 minus depth 2. So 62.5 minus 1.63, and the value of invert level for MS2 is 60.87 meter. Okay, this is the sewerage flow direction. Okay, the red arrow is the sewerage flow direction for our project. Okay, next, the proposed sewerage treatment plan, STP. Okay, the wastewater which is discharged by sewerage line will flow to the collection center, which is called sewerage treatment plant, STP. STP will remove any contaminants from wastewater, and it is located at the lowest place so that the wastewater can flow directly into it. The detail of STP proposed level is stated below. Based on the invert level of manhole, the proposed platform level is 49.2 meter. The depth of proposed STP is 2.57 meter, and the STP invert level is 46.663 meter. Okay, this is the proposed STP layout plan for our project. Okay, next, the calculation of total population equivalent. Number of unit house is 60 unit. So the total population equipment is equals to 60 unit multiplied by 5 population equivalent per unit, and the value for total population equivalent is equals to 300 population equivalent. Thank you.
Hi everyone, my name is Leong Kai Yao. Now I will continue with the part of structure for this project. For manual calculation of slab, so we choose the two-way slab as an example for these presentations. So the two-way slab is from the section of CF34A, as you can see in the diagrams. So for the characteristic action for this slab, so the GK we choose and we use 1 kilonewton per meter square, which is excluding the self weight of brick. And also the GK is 3 kilonewtons. So for the design life for this slab is 50 years. And also the fire resistance is R60. The exposure causal is a XC3. So the basically two-way slab is so how we know that is two-way slab? Where is the value of Ly divided by the short spans is less than 2. So for this result we get the 1.21, which is less than 2. For the material for slab, the characteristic strength of concrete is 37 Newton per millimeter square. For the strength of steel, FYK is 500 Newton per millimeter square, and also the unit weight of reinforced concrete is 25 kilonewton per meter cube, based on the table. For slab thickness, the minimum thickness for fire resistance is 120 millimeter. So we're using the formula to calculate the thickness considering deflection control. We get the 120 millimeter. So we try the slab thickness is 150 millimeter. For the durability, the minimum cover with regard to bonds is 12 millimeter, and also the minimum cover with regard to durability is 20 millimeter. The required assist distance for R60 fire resistance is 20 millimeter. So we can calculate for the minimum concrete cover. We get the 14 millimeter, and then we calculate for the nominal cover. We get the 24 millimeter. So we try the nominal cover is 25 millimeter. For the action, the slab cell weight is 3.75 kilonewton per meter square, and the permanent load is 1.0 kilonewton per meter square. So we get the permanent actions and also the variable actions. So we calculate it for the design action, and we get the 11.18 kilonewton per meter square. So for the analysis, just now I said that the long span is divided with a short span, which is 4,350 millimeter divided by the 3,060 millimeter, 600 millimeter. So we get the 1.21, which is a two-way slab. So for the simple supporter slab movement, the short span using this formula, and we get that the moment for short span, which is 16.34 kilonewton meter per meter. For the long span, we get the result is 7.23 kilonewton meter per meter. And then for the main reinforcement, so we get the effective depth for the short span, which is 190 millimeter, and also the effective depth for the long span, which is 107 millimeter. So we calculate the moment for the short span, and so finally we can get the minimum reinforcement area for short span, which is 331 millimeter square per meter. So we use H10 200. So for the long span, also we repeat the following step for this long span. So we get the minimum reinforcement area is 368 millimeter square per meter. So also use the same H10 and 200. For the shear design, the maximum design shear force is 20.16 kilonewton per meter. So for the design shear resistance, we calculate the result, and finally we get that the design shear resistance is 65.7 kilonewton, and the minimum for the shear is 71.7 kilonewton. So we know that the design shear resistance equal to 71.7 kilonewton, which is larger than the maximum design shear force. So the result is acceptable. The next step is for the deflection. So we calculate for it, and also carry out the cracking. So we get that the result is very dirty. So finally we can get the detailing for this two-way slab, and also use the reinforcement with H10 200.
Hello, my name is Muhammad Fazli, and I will continue our presentation on the manual calculation of simply supported beam. As you can see in the figure, our chosen beam is beam 3/A2B, and which has the effective span of 3450 mm. The characteristic permanent action on the beam is 15 kN per meter, and the characteristic variable action is 10 kN per meter, with design life of 50 years, fire resistance of R60, and exposure classes of XC1. The material used in the beam is characteristic strength of concrete of 20 Newton per mm square, characteristic strength of steel of 500 Newton per mm square, and unit weight of reinforced concrete of 25 kilonewton per meter cube. The assumed diameter of bar is 20 and 12 millimeter, and the diameter of link of 18 millimeter. The beam size for this project is 450 mm depth and 150 mm width. First, we calculate the durability, fire and bond requirement of the beam. The minimum concrete cover regarding to bond is 20 mm. Minimum concrete cover regarding to durability is 15 mm. The minimum required exit distance is 40 mm. The minimum concrete cover regarding to fire, we can just calculate from the minimum exit distance minus by diameter of link minus diameter of bar divided by 2, which we can get 22 mm. The allowance in design for deviation, we can just get 10 mm, and the nominal cover is calculation of C minimum plus by design deviation, and we can get 32 mm. So in this project, we use the nominal cover of 35 mm. Next, the calculation for loading and analysis. First is the beam self-weight calculation. We can get from multiplying the beam height, width, and the 25 with each the unit weight of reinforced concrete, and we can get 1.69 kilonewton per meter. The permanent load excluding the self-weight of the beam is 15 kilonewton per meter from previous, and then the total characteristic permanent action is 16.69 kilonewton per meter. The characteristic variable load we can just get from the requirement before, which is 10 kilonewton per meter. The design action we calculate from the formula of W equal to 1.35 GK plus 1.5 QK, and we get 37.53 kilonewton per meter. The shear force and bending moment for the beam we calculate from V equal to W L over 2 and M equal to W L square over 8, and the shear force is 64.7 kilonewton per meter, and the bending moment of the beam is 55.84 kilonewton meter. Next, the calculation for main reinforcement. First is the effective depth. We can get from the calculation of D equal to H minus C nominal minus of diameter link minus diameter bar, and we get the effective depth of 387 mm. Then D pi we can get from C nominal plus by diameter of link plus diameter of bar equal divided by 2, which is 49 mm. The design bending moment we can get from previous calculation, which is 55.84 kilonewton meter. Then we can calculate the K value from the equation. K equal to M divided by BD square FCK, and we can get 0.124. Next, the calculation of K balance. Using the formula stated in the slide, and since we get 0.167. Since K balance is bigger than the K value, so compression reinforcement is not required. Next, we calculate the Z value from the equation, and we get 340.56 millimeter. And the area of reinforcement we get is 376.93 millimeter. The minimum reinforcement area from the calculation equation we get 87.43 millimeter square, and the maximum reinforcement area we get from multiplying 0.04 by height by width of the beam, and we get 2700 mm square. Next, the calculation for shear reinforcement. The design shear force we get from previous calculation we get 64.74 kilonewton, and then using that value we calculate the concrete strut capacity, which from the equation we get two answer, which is 110.34 kilonewton when we use the angle of 22 degree and cotangent angle of 2.5, and 160.22 kilonewton when we use 45 degree and cotangent of 1. So since design shear force is below than concrete strut capacity, so the angle for the beam we use is below of 22 degree. So using the calculation of degree equal to 0.5 sine, we get the answer of 9.94 degree. The shear link calculation we can get from as shown, and which the answer is 0.17. So from that we try link H8 and the area of shear of 101 mm square. So the spacing we can just divide 101 over 0.20, so we get 505 mm with the maximum spacing of 0.75d, which we get the answer of 290.25 mm. So in this project, in this beam, we use H8 link with spacing of 250. So the minimum link we also calculate using the formula, and we get 0.107. So we use the same link H8 and the area of 101 mm square, and the spacing we use to 101 over 0.11, so we get 918 mm, but it is bigger than 0.75d. So shear resistance of minimum link we use from that equation, and we get 152.44 kilonewton. Since shear resistance minimum is bigger than shear force, so link arrangement is not required.
For the floor of project, for this STEAM for software, so in this project is a semi-detached house project located on the KM 21 kilometer from at the Jarang Gulang Meseng. So this project consists of 120 semi-detached double story houses. So we design this houses for the residential is basically using the double storage houses. So our main focus on this project is only on the first two units, which is located on the corner lot of the construction site. So in order to design this building, we need to specify the parameter for the design of building correctly, so that in order to prevent any incorrect result. So for this, we specify the design of building by design all the column, the foundation, and also the roof, the slab in the building. And as you can see that this video show that how the result, and finally we can get the result for this project. In discussion, the first one is the type of foundation. So for this project, we are using the paved footing for this project because it is swallow foundation, which is suitable for resistant constructions. So as we know that the paved footing is very common, the foundation which is widely used in the construction industry. So the advantage is of this paved footing is to prevent structural sliding and other movement and allow the building on the ground, so that if insufficient, otherwise the floor or the ground will have a insufficient bearing capacity. So as you can see the diagram, which is the houses that we design for double storage houses. So for the slab thickness, in general, the slab thickness ranging from the 100 millimeter until the 150 millimeter are appropriate for residential and commercial constructions. So the thickness that we use in this, the thickness of a slab that we use in this project is 150 millimeter. So the reinforcement for the slab is T10 250, which is the reinforcement area is 340 millimeter square. So as you see the diagram shows that the example of a slab thickness of the building.
Next on the discussion is the type of reinforcement used. In this project, we use deformed steel bar for the reinforcement. It is a steel bar with surface deformation such as spiral shape, herringbone shape and crescent shape, as we can see in the figure. The deformation of the bar is to improve the connection and friction between the bar and the concrete, so it will have bigger fatigue resistance and narrow fracture width. It also have high bonding strength and high flexibility.
For method statement of site clearing, they use machinery, tools and equipment such as hydraulic excavator, wheeler lorry, dump truck, roller and compactor. For construction procedures, trees within site boundaries are to be removed and replanted according to authorities' requirement. Hole will be backfilling with suitable material. The method and site for relocation of such trees shall be agreeable during the site visit, either with bare root or with a soil board. The surveyor will carry out the survey works and pegging out the boundaries of working width for the site clearing areas. Site clearing work will be carried out by using hydraulic excavators and wheeler lorry. Removal works will be carried out by using hydraulic excavators and wheeler lorry. For safety and health of site clearing, job safety and health analysis shall be carried out the project site. Caution and awareness shall be established at location of work, such as the signs and the hazard in particular activities, and the control measures implemented shall be briefed to the workers during safety induction, providing the workers with all necessary PPEs. For work involved with deep excavation, a proper barricade must be arranged surrounding the excavated area. All workers employed in the project site must have CIDB green card. For process for road curb installation, the machinery, tools and equipment used in this process is excavators, triple or dump truck, vibrator roller, back pusher, concrete grade 20, BRC A6 and precast concrete road curb for L shape and I shape. The construction procedures are: excavation shall be carried out by a backhoe to 230 mm average depth as shown on the drawings, commencing from platform level to form subgrade to receive paving and removing excavated material from site. Next, trim, grade root and compacted root subbase by roller to required cambers and gradient. Next, precast concrete curb shall be cast using steel mold and shall be of the types curb should be laid with joint as narrow as possible and filled with mortar containing 1 part Portland cement to 2 part sand. For safety and health of this process is job and safety health analysis should be carried out the project site. Caution and awareness of signs shall be established at location of work. The hazard in a particular activity and the control measure implemented shall be briefed to the workers during safety induction. Next, all workers employed in the project site must have CIDB green card. And lastly, all new workers and staff to attend the safety training or safety induction course before commencing work at the site, and attendance shall be recorded in an induction checklist. For the problem solving relating on infrastructures work on site, the first problem that the engineers had tell us is encounter boulder during excavation activities. For this problem, they use a solution such as hacking and chemical demolition, which using betanomic. Without explosion, the boulder will crack itself. And the next problem is blow count is above pile penetration requirement. So for this problem, the solution they suggested is by take measurements to determine if the problem is related to the driving system or to soil behavior, and do an investigation on how to solve the problem to further solution. And the last problem that the engineer told us is piles are driving out of location. For this problem, the solution is spudding or pre-drilling of pile location.